Okay. Good evening. Welcome. Let's look at this question from Limpopo term 3 test. Probability of A. Probability of A is given by 0.45. Probability of A and B is given by 0.135 if A and B are independent events. The keyword independent, probability of B. Now for them to be independent, we know that probability of A and B is equal to what? Probability of A probability of B. That happens if events are independent, as indicated here. So now probability of A and B is given by 0.135. So it's equals to probability of A is given by 0.5 times probability of B. So then probability of B is equals to 0.135 divided by 0.45. So probability of B is equals to 0.135 divided by 0.4 divided by 0.45, that gives us 0.3. So probability of B is 0.3. 2.2 A, B, and C. There are three events. Probability of these events or any other combination of them occurring is given. First bullet, probability of B 0.6, probability of B and C but not A, meaning that this is B and C only, is 0.15. Probability of A and B but not C, again this implies that it's A and B only, B only 1. Probability of this is a complement, which means not. That's a complement, which means not A or B is equal to C but not B, meaning that again this is it's only. We've done that, so say what? Draw them diagram. Saying draw the Venn diagram. So let's see how best can we draw this Venn diagram here of this event. You can see that the events have been A, B, and C. So when we draw, they didn't tell us whether these events are or not. So when we draw this, let's have them in a second. So here I'm going to draw my Venn diagram. I'm going to do one. So let's pick first event A. This is my event A. I'll pick the second event. This is event B. This is event B. I'll this event C. Okay, let me make A bigger. So that I can have it in the right space. Let's make it bigger. I can have it let me make my A a bit bigger. Yeah, that is A. Then I will join this here. So now let's of this now. Let's start probability of B. I will write this is 0.6. Why? Because this is where B is. Probability of B and C but not A. B and C not A, it's here, which is a B and C only. So here it's 0.15. Probability of A and B but not C, it's here, which is 0.14. Probability of B only is 0.1. So now I can see that I need the intersection. So what happening here is, when I deal with the probabilities here inside this B, they must give me 0.6. That 0.6 is a sample of B. Is a sample of B. So when I add this and this intersection, should give me 0.6. So let me work on the intersection. Follow them. 0.15 plus 0.14 plus 0.21. This is equals to 0.5. 0.6 minus 0.5. This gives. So now I can say with the space they said probability of not A or B is equal to C equals to A and C. So it's these parts I will call this is X, that everything here is x, so this is x, this is x, so this is x over 3. So that's my Venn diagram. Remember that the sample space here it's 1. Why is it 1? Because I'm given the probabilities. So we look at 2. Let's look at 2. Say determine P probability of C only and hence A only. Let's start with C only. What happens if I add all these probabilities inside the circles? Not this, not that, but this circle should give me 1. So I'm going to have x plus, this is the x, plus this x, plus this x, plus x over 3, plus, now if I look at this, all other numbers they are in B, which that give me 0,61. The 7 1 plus 1 plus 1 plus 1 over 3. So this, remember, this is over 1, this is over 1, this is over 1, so I'm adding this, will give me 10x over 3. That is 10x over 3 is equals to, transposing this side, this is 1 minus 0,6, so that is going to give me what? 10x over 3 is equals to 0,4. So I multiply that by, so I'm going to have 0,4 times 3 divided by 10. So my x is 0,2, meaning that this is 0,12. So the probability of C only is 0,12. So probability of A only is 0,12 divided by 3, which is 0,04. Okay, they say now 2.2.3 are events A and B independent. Justify your answer. So we know that for independent, we're talking about A and B. So probability of A and B is equals to probability of A times probability of B. If this happens, the answer is yes. The answer is yes. But if probability of A and B is not equals to probability of A times probability of B, then the answer is no. So not because the question is asking us, we can conclude. Let's probability and be careful of this. There is A and B only. This is A only. There is A and B. So where is A and B? This is A and B. This is A and B. Where A and B is. So A and B, it is equals to 0,14 plus 0,1. That is A and B. So it's 0,14 plus 0,1. That is 0,24. So now we need probability of A, because of B we know it is 0,6. So probability of A, this is probability of A. This is probability of A, where A only is 0,04. So we add everything, 0,04 plus 0, this is 0,12 here, 0,12 plus 0,12 plus 0,1 plus 0,1, that will give us 0,4. This is 0,4. So probability of A times probability of B. Let's check. Of B is 0,6 times 0,4. So let's check this. Times 0,6 times 0,4, which that give us 0,24. So we look at probability of A and B 0,24. Then our answer is yes, they are independent. The reason will be probability of A and B is equals to probability of A times probability of B. Okay, we've done that. So now let's go to the next question. Question 2.3. 2.3. Push it this side. Right at the left side of it. Okay, they say the 3-digit 1, 2, 3, 4, 5, 6, 7, 8 are used to form a 3-digit code. How many codes can be formed if now repetition? If digit may repeat, repetition allowed. Repetition allowed means that the sample space remains the same. So this is 2.3, 2.3.1. We need to make 3 digits out of the rest. We're going to use what? Repetition is allowed here. So that means for the first digit I can choose 8, for the second digit I can choose 8, for the digit I can choose 8, because the sample doesn't go down because of digits remain the same, which that will make it what? 5, 12. Or we can say this is NR. N is the sample, R how many times we are choosing. So our sample is 8, we are choosing it 3 times. So this is 5, 1, 2. So it's 2, 3.2. Digit not repeat. Now if digits are not allowed to repeat, the sample space go down. So we're still going to make 3 digits code. Now for number 1, for the first digit I can choose out of 8, for the second digit I choose out of 8, I can choose out of 6. So which this makes it 8 times 7 times 6, which is 3, it is 336. Remember why? Because as we are choosing the number, we can choose it again. Or we can even say n factorial over n minus r factorial. How many? 8 digits. How many digits is 8? We need how many? We need. So now this is in factorial. So we can do that. We can say it's 8 factorial over 8 minus 3 factorial, which this will give us what? 336. This happens if repetition not allowed. This happens if repetition allowed. So we can do this in 2 ways. So here let's go to 2.3.3 and read the question. The code is an odd. The code is an odd and is greater than 300. So let's focus on. Let's start with the greater than 300. Look at the first digit is 3, meaning that the code should start with a number more than 3. So we can start with 3, yes, 3 and upwards. 3, 4, 5, 6, 7, 8. If we start with one of this code, then now the code will be greater than 300. So why 300? Because 300 have 3 digits. Also this will give us the record 3 digits. So this have to be the first digit. Then for it to be odd, let's focus on the part of odd. For it to be an odd, the last digit must be odd. The last digit must be odd. The last digit must be odd. And how many odds are there? We have 1, 3, 5, 7. So this have to be the last digit. Remember, the question says digits may not repeat. So we choose a digit 1. If we choose a digit as the first, it can be on the last. So let's focus on the question now. Okay, now we do it here. Let's start with the odds. I want to deal with the odd part. I want to start with all the first digit being odd. So how many are odds? If I come out of this, I have odds. I have 1, 2, 3. I have 3 odds to start with. So I'm going to start with the first odd, which is 3. If I'm going to start with 3, so I'm going to say I have 1, 3. This is the middle number. Then I have how many to choose from? I can't choose 3, so I can choose out of 3 because I can't choose 3. Then I've chosen 1 and 1 here. So now I'm left with 6. This is for the first code. For the second code, I'm choosing 5. If I choose 5, I have only 1 5. So still for the last digits, because I've chosen 5, so I can choose last out of 3. So for the middle one, I left 6. Then if I choose 7, I have 1 7. So still the last digit will remain pin 1, pin 3. So I have 6 to choose from. So this makes it 18. So I can make this codes, which is 18 times 3, can make 54 codes. 54 codes. If I'm starting the code with the odd, I'm starting the code with the odd and ending with the odd. So let's go when I'm going to start it with the even. That means I'm going to start them with the even. So by starting with the even, now that means that I'm going to keep 4 odds. Now I'm going to start with the even, which is 4. I can start with the even, which is 4. So I can start with the even. How many evens do I have? I have even 1, 2, 3 evens to choose from. But how many odds to choose from? Remember, these 3 events will give me more than 300. And how many odds to choose from? I have 4 odds to choose from. Then now in the number between, I can choose out of 6, or I can pick an even, goes with this, all the odds, choose an even, goes all the odds, choose an even, goes with all the odds. So here I'm going to have what? 3 times 6 times 4, which this is 72. So the codes that I can make, I add the 2, it's 54 plus 72, which this is 54 plus 72, which I can make 126 codes that are more than 300 and being an odd, meaning that when I have that number has to be an odd.